In the figure below, what is the length of RS? Note, figure is not drawn to scale. So I'm looking at the figure and I want to identify where RS is because that's the length that I want to find. Here's R, here's S, and here's a line segment that I want to find out. Before I can really get started with this problem, I need to look at the figure and see what information it's telling me. There are a couple of side lengths, a 6, an 8, and a 5, and it's also giving me a couple of right angles here and here. Now this one I had to pause for a minute and think about, what is this really telling me? Here I have a right angle, and here I have two side lengths. Well, if I make this a triangle, if I draw a dotted line right here between vertex R and vertex T, now I have a right triangle such that I know two side lengths. Well, for any right triangle, when I know two side lengths, I can find the third side using Pythagorean theorem. So down here, I'm just going to show my work. I'm going to use Pythag, which is a squared plus b squared equals c squared. Here's the shorter side, here's another short side, and across from the right angle is the hypotenuse that I want to find. So now I can plug in my 6 and 8 into my formula so that I can find this missing side right here. Okay? So I'm going to plug in 6 squared plus 8 squared equals c squared. Can simplify, 6 times 6 is 36, plus 8 times 8 is 64, equals c squared. This equals 100. And now, to get c, I need to take the square root of both sides. So square root of 100, square root of c squared, and now I know that c equals 10. So this missing side, or the hypotenuse of the right triangle that I made, is 10. Okay? So now when I look at my figure, I now have a 10, a 5 right here, but I still need to find this side length. I see a right angle, and I've made this so that it's a right triangle because of this 90-degree angle. So again, I can use Pythagorean theorem to find this missing side. So the triangle looks something like this. Oops. Where this is the 5, here's something I don't know, and here's the 10. So using Pythagorean theorem, let me write out a squared plus b squared equals c squared. Here's my a, plugging it in. This side I don't know, so that's going to stay the same. The hypotenuse, which is directly across from the 90-degree angle, is 10 units. So that's what I plug in for c, because c is the hypotenuse, and now I need to simplify. 5 times 5 is 25. Bring down the b squared, 10 times 10, I know that's 100. Let me subtract off 25 from both sides because this is an equation. On this side, I'm just left with b squared. And on this side, 100 minus 25 is 75. And then to solve for b, I need to take the square root of both sides. So now I have b equals the square root of 75. But I'm not done yet, because when I look at my answers, I don't see anything that looks remotely close to the square root of 75. I see a couple of radicals, but it's not clear to me that any of those are screaming out square root of 75. So to make this answer look like something that's up there, I need to simplify by finding the factors. What goes into 75? Well, 3 times 25 is 75. 3 can't be reduced into factors, but 25 sure can. Becomes 5 times 5, and then after that I can't pull out any more factors. So the square root of 75 can be rewritten as, or is equal to, 3 times 5 times 5. Now that I know when I reduce radicals, if I find a pair underneath the radical, I can highlight them and then bump one outside of the radical. So here's my pair. I have a pair of 5s. I'm going to pull one 5 out. 3 doesn't have a pair, so it doesn't go anywhere. It stays right there. So my final answer is 5 square root of 3. And I go up here. 5 square root of 3 is b. So So I circle this, or really I'll bubble it in my answer key, and then that's it.